We have from Hamburg, our next two guests who are live here with us in the studio, ladies and gentlemen. And you may join me if you like, perhaps to my left, gentlemen. Hello. Thank you so much. I'm just going to start or finish my introduction better yet. We have, first of all, Dr. Steven Vettermann. For many years, he has been general manager of the prostep ivip Association, as well as international networker with focus on Japan and also LinkedIn blogger. Steven brought systems engineering into this association, is now head of the systems engineering cluster at prostep AG, and represents the company in the projects of the German flagship initiative for autonomous and networked driving. This is where the idea for today's presentation actually came from, so that's impressive. Moving along, we have Hans-Martin Heinkel from Swabia, a Swabian through and through, I've been told.
Totally.
Whatever that means, you can explain later, but a Swabian through and through. He has been with Bosch for more than 35 years now in systems engineering, control technology, and simulation division. For several years now, his focus has been on virtualization, which is also the reason for his great commitment to the prostep ivip Group Smart Systems Engineering project. Welcome on stage, gentlemen, and we now look forward to your presentation, Realizing Traceability for Safety and Certainty. And I would like to remind our audience that we will be saving a few minutes at the end of the slot for a Q&A session, as always. So now you may begin asking your questions already using the chat function. Gentlemen, the stage is yours. Thank you.
Thanks a lot.
Thank you.
Claire, for your kind introduction, and thanks a lot to ivip prostep for inviting us, and I hand over to Steven.
So thanks also from my side. As these are special times and special circumstances, we would like also to invite you to participate in an additional online session. The URL is given here because we are interested in receiving as much feedback as possible, also far beyond this event. So this session will stay alive. Just use it, contribute. We are open for any and interested for any comments out of the community. So coming to the agenda of today, I will give a brief introduction and the motivation about why we are here. And then Hans-Martin will introduce the needs of Bosch concerning traceability and his interest in driving standardization. Further on, I will introduce a little bit more the set-level project, the flagship project, and also introduce a demonstrator on traceability. And we will close up with some conclusions and a little bit a way forward. So when talking about industrial challenges, we have to talk about connectivity, we have to talk about mobility, autonomous systems, not only autonomous driving, but we also have to talk about regulations, and we have to talk about audits, becoming more and more critical for the industry. And of course, we are in an IoT world, and we know that not only the products are getting more and more complex, also the engineering life is more becoming complex. And when talking about these challenges currently, and especially talking about regulation and audits, we get to talk about traceability because this is a key aspect to make this possible. And when talking about standards or the regulation and audits, we also have to talk about standards. Standards do make our daily life easier, but with every upcoming technology, we also have to talk about new regulations, we have to talk about new standards, and we have also to talk about the availability of global standards, global regulations coming from ISO, coming from the UN ECE, for example. We are talking about German initiatives, French initiatives, Japanese initiatives on an industrial basis, on a more formal basis, and all this stuff has to be considered when we're talking about providing technologies for traceability especially, to make this really mature. And guys like the two of us, we like to make things possible and bring the right things together so that we have something which is fluently supporting our needs. Ms. Blair kindly also introduced my heritage, let's phrase it like that. But when I was general manager of the prostep ivip association and driving forward the smart systems engineering project, I didn't thought about that it would be such a success story. So currently led by BMW, over 20 partners are creating best practices for collaborative systems engineering. And one cornerstone within this initiative is quality traceability, and it's headed by Hans-Martin Heinkel. And who can better talk about the current available solutions, but also the concepts in future combined with the motivation why Bosch is caring for and why it's so important. So please, it's better to take it over.
So thank you very much. So one reason, because we can't solve these problems alone. And so we need partners, we need the whole industry to solve these problems. And now I want to focus a little more on the Bosch perspective on this topic. What you see here is a short overview about the Bosch company. Bosch is a very big company and we have a lot of different business fields. And therefore, we also have to support all our products through the whole life cycle. I want to show that a little more in detail with that little graphic. So what you see here is a whole cycle from the beginning, so from the requirements engineering, from the production to the usage. And what are now here the main points from digitalization and virtualization? So one big point is we have to connect the information and data through all domains. But another very important point is simulation. So real prototypes will be replaced by virtualized prototypes. But that also means that we will more focus and we really need that we make our decision and also the releases that will be based on simulation results. And that means especially the traceability aspect is very important for simulation. And what is the status in the moment? We already have very good simulation environments. That's not the point. But a weak point is that these simulations are islands and they are proprietary. And they are only weak connected to other engineering domains, for example, to requirements engineering or to test engineering. And that is the reason why we are focusing now on a simulation process which combines and connects these different engineering domains. What you see in the middle, the green one, that are the basic phases of the simulation process, left and right. The white blocks, they are the connection to the other engineering domains, for example, to requirements engineering. And what you see here, so the different phases are already quite good supported by all kinds of tools. But what is missing for the flow of information, it's not really good supported by the tool infrastructure. And that is the reason because we need here for traceability a connection of these information flow through the whole process. And that means, and that is our solution approach, therefore we introduced a metadata schema, tool independent, and which can be readable by machines. I will now go a little more in detail. So our schema represents also the schema of the process elements above and how does it work. For example, in the phase requirements engineering, the tool which supports that phase can read the information from the metadata schema, work with the data, and write back the information to the schema. And then in the next step, the other tool can also get that information and work on that one, and so on. And that means that the meta schema is built up step by step. And that is where the name glue particle comes from. So we glue together the information from the whole, from all information phases along that chain. And that is a real point and our basis for traceability. And a short interim conclusion. So one challenge of digitalization is decision will be made more on simulation results. And our approach, therefore, is the credible simulation process together with our data schema, our so-called glue particle. And our main three constraints are here traceability, use in heterogeneous environments, and cooperation with partners. And these are really the key points where we focus on. In my part, I was more focusing on the theoretical approach we do here. Now, the main question, can we use that in industry? And what is the status here? So in the moment, we are running the first proof of concept projects at Bosch. And for the more practical part, I will hand over to Steven again.
Thanks a lot, Hans-Martin. Yeah. So one of these practical parts is done within one of the flagship projects in Germany, which is called Z-Level. And Z-Level thereby stands for Scenario-Based Engineering and Testing. It started last year, and it will run until 2022. You will find as project partners the who is who in industry and in research, heading forward to enable consistent virtual verification and validation of automated and autonomous vehicles in that part. And regarding that, assuring functional safety, and on the other hand, realizing traceability is one of the major cornerstones of this project. So Hans-Martin already introduced the credible simulation process, and of course standards are important for all the participants within the project. So after evaluating this credible simulation process and the underlying formats, we took the decision to drive forward and to take this as the basis for next steps, also to drive within these research projects. And by the way, the idea and the decision to do so was done the symposium before the last. So this is also a kind of cradle of new initiatives to drive things forward and to standardize and to support with standards the industry. So what is the most impact on that? Why do we do that? This credible simulation process helps us to bring together all the relevant or the necessary information and to arrange the relevant artifacts onto a digital thread. And within the project, prostep has the challenge but also the honor to realize a neutral software demonstrator for realizing traceability, to support development of safety-critical systems, and on the other hand, also to support audit-related activities. We are not also building our concepts on the credible simulation process and other relevant standards on that, but also on configuration management standards like the ISO 10007 and so forth. And the aim from our side and the most benefits provided then to, first of all, to the project partners, but also then for the community, is to cross-link the relevant artifacts, to make the relationships between these artifacts persistent, to come up with change impacts, because We are talking about very complex systems. Changes are coming as much as possible up. So we have to track and to feedback this information back to the user. We have also components to be respected, to do additional analysis we have to do to talk about or to feed to the program managers and so on the status of a current project. We have to support reuse of these components and, of course, to support an optimization of the whole processes, the testing itself, and so on. As product owner of this piece of software, I'd really love to give you an overview and a direct insight, an online presentation of this software. But time is too short, so we were discussing how to do that, and we finally decided to give you a mixture between screenshots and the key benefits, just to highlight on which we are currently working and what we are currently also doing, discussing this with the project partners and to drive the things forwards to enhance our first implementations. Talking about our software tool, which we call in this project Tracy, we are providing several major functionalities to our audience. So, of course, it's traceability. But when you're thinking, when you ever heard about WP29 from UN's ECE, where in the very last part of this regulation just stands, you have to provide traceability and repeatability. The good part in these kind of regulations is that you do not have to, realize the technology. Therefore, we are currently providing first demonstrators and finalize that then in the relevant products. When talking about traceability and bringing that to industry, as Hans-Martin just said, we also have to provide project management. We also have to take care and to support the quality management and improvements. We also have to take care about the process optimization of the whole stuff. And just to give you some glimpse about the key benefits when taking what Hans-Martin introduced and taking these headlines, some key benefits of the application of this. It's not only about traceability. That means a digital thread from one piece to the other and so on. It's tracking back to the relevant information. You can drive impact analysis, but also you can do usage analysis or the reuse to support the reuse of the information. You can track changes, the consequences of changes. You can track the consequences of error. You can enhance the quality. You can drive where-used analysis. So, for example, model XYZ is changed. In which projects do we process or do we apply this kind of models, for example? That's taking what Hans-Martin introduced and building up a good stack of software. Then you can offer this kind of additional benefits beside the traceability itself. On the other hand, of course, we are all lazy guys. So the reuse of information, saving time, costs, enhance the quality by reuse projects, complete projects, by using process templates, by using additional already provided content, artifacts and all this stuff, at least the whole process support. That's also inherited by the functionality Hans-Martin invented. And of course, doing so, we are talking about standards. We are open. I was in the past also driving an openness initiative. So providing open solution, neutral solutions, providing transparency not only on the data to be exchanged, but also on the interfaces, the neutral interfaces we use, for example, OSLC for incorporating doors, for example, or all this stuff to pick up the artifacts and to build this digital thread. And of course, Never underestimate knowledge management. So one corner point is to collect all the additional information, not only to reference a model, also the intent, the design intent behind the model, to explain to the people which assumptions are taken. And this is gold in reusing models, architectures, and whatever. So when listening to Hans Martin, I'm pretty sure you figured out that he's convinced. And Bosch is driving forward traceability because they really see benefit. We got in the discussions with the project partners also the feedback, for example, from Ford, that our concept pretty fits well to what they currently realizes. We saw in the presentation of our friends just before, and we will see it in the presentation right after, as in, from our friends from Toyota, that, and we are convinced that we can generate additional benefit by complementing these kind of technologies and solutions with traceability, and it fits pretty well together. But now I was talking a lot, Hans Martin. Maybe I hand over to you the conclusion of our short presentation.
Well, one last sentence. So
always
Bosch,
the last.
We really see tremendous benefits in driving traceability. And also for the last one, but 2 more sentences. So what we are doing here, we have standardized information packages, and that is a real benefit. And the standardized information packages are connected to the simulation process, and therefore we need new toolings, and that is what Stephen presented. And that are our conclusions. So complexity will increase, so we need innovative and smart solutions. That's clear. And quality, safety, and legal acceptance is very important. And here we see traceability is one of the key. But traceability also we see in a little broader aspect. So traceability means for us, it must be cross-domain and across toolings. And that is what the credible simulation process supports. And now for the last 2.
Just, do you have the honor to click?
Okay.
Yeah, we're at the end. Thanks a lot for your intention. And please, it's all, I steal your words, but you do it better than me.
I wouldn't say that, but a round of applause, please, for our presentation here in the studio from our
Thanks
team.
a lot.
Thank you so much, gentlemen. And before we move along to our Q&A, we did receive a number of questions. We're going to just see how many we can get done in the next 6 minutes. May I ask you this, Stephen? Can we enter a first-name basis?
Yes.
Is that okay? All right. So, Stephen, you mentioned you put a lot of emphasis towards the end of your part of the presentation to not underestimate the importance of knowledge management. Is that something that you experience in your environment, that it has been or is underestimated often?
Yeah. When you start, and we are technicians.
Yeah.
So we like to talk about interfaces and artifacts and all these architectures.
All the exciting things.
And then suddenly you say, hey, if we put this additional, some sugar on it, and then you see, hey, this is a gold mine. Then you can push processes, you can make life easier and understandable. And so the more we were talking about technology, the more came up to my mind, we're talking about knowledge management.
All right, so it's a process.
And here I have to add something, because knowledge management, in my opinion, has in the moment the problem, you get pieces of information, but you don't need to really see what is the quality. You combine things, but what is the overall quality? And that is a very big advantage here. You have an information package, and it's done out of a project. So there must be some quality label on that row. And that is the main important things where we think we can add some benefit also to information management.
Definitely sounds like it. Thank you. Gentlemen, why don't we move along to our viewers' questions, and thank you once more for participating to all of our viewers. Now we have from Miro Marvin Schmidt, is this stepwise filling of metadata meant as a manual export-import procedure, or do you already include a way to automatically update this data when changes are applied in the tools? You can read it yourselves.
So it must be, and in our prototype it's automatically so, because a lot of tools already have the information inside. I know a lot of simulation tools, and they already have the possibility for an XML export format, but it's different structure. So it's only a restructuring of the information. The only thing what is missing, no tool knows what the person behind the computer is thinking. So he had to add these things. That is always the case. But all other things must be automatically, otherwise it would be dead.
All right, that does sound fairly logic. Yes. I would say thank you for that. Next question comes from Gray. What existing industry standards for traceability are in play for the SET level project? What is the biggest standards gap that the project has identified, let's say, so far? I'm looking towards you again. Is that
good question? But I think make it both. So, for example, there's also the MOXA standard coming up, and we see that is more focusing on data standards, and we are more focusing on process standards. And we give a framework for the phases, and inside we have to use other standards. And it's a framework which can be supported, but we need other standards to fill it up. And that is will be the ongoing work.
So it's pretty complementary. As you said, we took additional standards like the Mossack standard, but also inherit information from STEP and different other standards. What we do is to make it more flexible with our process standard and to collect the different, like a harvester, going around and getting all this information and to provide a very smart and lean solution for that.
And it's very important, we really look for a very lightweight solutions. And our goal is that we can use it next year. Because often the problem is that standards are very huge and you have to wait for 10 years. And that's too long.
That is definitely way too long, especially in our time and age.
Yep.
Speaking of too long, let's move along to the next question quickly so we can cover one more, okay? As long as we're still within your slot. Now, we have from Miro Jens Kruger, NTT data, is this simulation process metadata in XML related to BPMN as the process aspect is also important for traceability? Is that relation accurate?
Well,
are you amused?
No.
You do look so a bit, just a bit.
No, I'm
it's a good
not
question.
familiar with that standard BPM. Do you know?
No, it's a vehicle. Let's phrase it like that for orchestrating the processes and for driving forward the processes. If you're doing this kind of work, and to all the others, of course, too, then we are below that part because we are implementing into the organizational stuff, the really doing, and the tool support by that part. So one can combine it, but currently we are first of all providing, like Hans-Martin just said, the solution, and then broaden and addressing all the different domains. Yeah.
I think we have to give here some background information. So we didn't want to make a standard from the scratch. So here we were using the Modelica standard system structure and parameterization, SSP, and we use a lot of features which are inside, and we only make some additional things. So basic is a Modelica standard SSP.
Okay, so that might have been a slight misperception, but thank you for explaining. And gentlemen, that's all the time we have, I'm afraid. But you have a wonderful way with words, I think, and a wonderful way of making things very understandable. Take it from a non-expert, so thank you so much for that.
Thank you too.
And thank you for your contribution. All the best.
Welcome.
Thank you.
Thanks a lot.